Hey guys, how's it going? So welcome to AD Intuition AI, and today we'll be solving Leetcode question 1010, which is pair of songs with total duration divisible by 60. So let's get into it. So in this question, what has been asked is that they have given that you are given a list of songs where the ith song has a duration of time I seconds. Okay, and return the number of pair of songs for which their total duration in seconds is divisible by 60. Okay, formally we want the number of indices I comma j such that I less than j with time I plus time j uh, divisible by 60 basically. So they have also given an example where they are saying that 30 plus 20 plus 150, 30, 20, 150, 140, and they are saying that the three pairs have a total duration which is divisible by 60, and you can see that 30 plus 150 duration is divisible by 180, and then 20 and 100 duration is divisible by 120, and then 20 plus 40 duration is divisible by 60. And they have given three songs which have duration of 60, and now if we look into the pairs, the output is three. Pair means that 60, 60, 60. So these three will form three pairs. So basically, let me explain you what the question is trying to. As in the question, as we can see that they have given this time array, which is showing these timestamps, and they want to know how many pairs of songs are actually divisible by 60, right? So we can see that 30 plus 150, this duration is equals to 180, and when you divide it by 60, the remainder is basically 0. Similarly, if you will look into it, 30 plus 100, 130 is not divisible, 30 plus 40, 70, it's not divisible, 20 plus 100, 20 plus 100, the total duration is 120, and if you divide it by 60, it is divisible by 0. And similarly, 20 plus 40, the duration is 60, and when you try to divide this, then the remainder is 0. So in all these three cases, one thing is very clear to us, that we need two different songs, and in these two songs, we need to add them up, and then duration needs to be divisible by 60. Now in this question, the another one where they have given 60, 60, and 60, this array, right? And now here, as you can see, this is one pair. 60 plus 60 would be 120, and when you will divide it by 60, it would be basically 0. Then one is this pair, and then one is this pair. So this way, this output turns out to be 3. And over here also the output is 3. Now there's one very good mathematical explanation on how things are being done, and I think we should remember this because this is very important and can be useful in solving many type of questions. So the whole logic here is that for any two numbers to be divisible by 60, right? To be divisible by 60, and this modulus operator is basically something that we use to get the remainder, right? So if we want the remainder of anything, we use this modulus 60. So here two cases can be there, right? Like if you want both of them to be divisible, now one can be that A is divisible by 60 and is B divisible by 60. Like this is equals to 0 and this is equals to 0. So they're combined. If I consider this as R1, right? This is R1 and this as R2. So then R1 plus R2, this can be equal to 0, and if the remainder is 0, then if we will take the modulus of the remainder, it will turn out to be 0. Or the other scenario can be that whatever is the remainder of these two, right? This one and this one, which I'm saying R1 and R2, the remainder of both of them should add up to 60. Like it should be 60, so that when we try to divide the modulus by 60, we should be able to solve this up, right? It should be 0. So there are two cases that we can do in this, that either the remainder should be 0 for both, or the remainder of both of them should add up to 60. And if either is the case, then what will happen is that we will be able to get the number of pairs which are divisible by 60. Now, this question can be solved in two ways. Now, let's go back to the question. So first way is that here is the time, right? So approach one can be, this is the approach one, which is like the brute force approach that can be used. Here what we can do is we can iterate through the loop, right? Like the loop here is 30, 20, 150, 100, and 40. So what we can do is we can iterate through the first loop, like for I in range, then the length of this array, right? And we can keep a inner loop, which will basically start from I plus 1, and it will run till the length of the time. So now here, if you'll see, if our first element is 30, right, then the second loop, then it will check whether 30 plus 20 is divisible by 60. If 30 plus 150 is divisible by 60, 100, 40. Similarly, then is 220 plus 150 divisible. So if this way we will do, we will be able to find out the count of all those pair of songs which are actually divisible by 60. And the time complexity of this loop will be order of n, this loop will again be order of n, and the combined time complexity will be order of n square. And the space complexity will be order of 1 because we are not using any particular data structure, so it should be good. We should not be needing any extra memory. Is the second approach that we can take in order to improve our time complexity is the approach of using a hash map. In the previous approach, we saw that the time complexity was order of n square. Here, what we can do is that we can create a hash map of remainders, like for example, and we can keep a count of number of times that element has occurred in the hash map. For example, when we do the modulus of 30, then the remainder is 30. So we create a hash map which has 30, and now since it has occurred once, we will keep the value as 1. Now we do 20 modulus 60. It will be what, 20? So it will be 20 and the count will be 1. Now we go to 150, right? So we can see here that the 150 modulus 60 would be equals to 30. And now 30 is already in our hash map, so we will increase the count of this 30 to 2. Now we will go to 100, and 100 modulus 60 will be equals to 40. The remainder will be 40. So we will add it to the hash map. And then 40 modulus 60 would again be 40, and the count of 40 is already there, so we can add it too, right? Now, and if your remainder is 0, like for example, in the second case, right, where the hash map would have been something like 0, right? Now we can see that the frequency for the first 60, 1, for the second 60, it is 2, for the third 60, it is 3, right? So anytime we are able to find an element in the hash map, we will increase our counter with a frequency of that particular remainder. And this way, we will get the number of total pairs that we are trying to do. If there is some confusion in this approach, it will become more clear when I will code it. And in this one, because we are iterating through the entire loop once, so the time complexity will be order of n. And because we are using the hash map, so the space complexity will also be order of n. Now let's get to code, and I'll show you how we can code this up. Now here we start with the first approach, and our first approach is the brute force approach. So let's start with this, right? Brute force approach. So for the brute force approach, we do not need any particular data structure, but we do need to maintain a count. So we will keep the count as 1. Then we will do for I in range. Oh, sorry. Range will be length, and length is of time, right? And the inner loop has to run from I plus 1. So time. Now any time the summation of both these values, like the value which is at index I and the value which is at index j, if their summation is actually divisible by 60, then which in other way the word means that if the modulus 60 is equals to 0, then we can simply count plus equals to 1, and then we can return the count. Now let's see. Let's run the code and see. Okay, so we're getting the wrong answer. We are getting the wrong answer because count has to be initiated to 0, not 1. My mistake. So now you can see that the solution is accepted, right? And if you will try to run the submit the code, I think you should get time limit exceeded because I've already run it, and because the time complexity is order of n square, so it will be time limit exceeded. Yeah, we got that. So yeah, so this is the brute force approach with a time complexity of order of n square, and the space complexity is order of 1 because we are not using any extra memory space. Now let's see this one, how we can optimize the time complexity in this one. And so our approach to would be using the hash map. So for using the hash map, our approach is using the hash map. So we'll create a hash map of remainders, and we are using like instead of regular one, we are just using default dict. And the reason for using default dicted and we will initiate the value to integers is because if the value of remainder is not present, then automatically default dict will give 0 as the value. Otherwise, in case of regular hash map, it will throw an error, which is not good for in our case. So because we need to have some sort of like value sent back if the remainder is already not there. So because of that, and now count will initiate to 0. So 40 in time. So now if your t is basically divisible by 60, then what you do is that you add whatever is the value of 0, like 0 remainder, to your existing count. And if that is not the case, then you simply add whatever is the value of the remainder, which is 60 minus t modulus 60. Whatever is the remainder that you, because we started and we are doing this, let me show you why we are doing this. We did here, right, in the approach to we did it right here, right, that both the remainders have to be both have to add up to 60. So if one, which is the 60, which is like here when we calculate I by 60, right, so this can be an R1 or an R2. So the other remainder will be 60 minus R2, and we are doing this, and so we could do the count to this, and after all this we will simply add whatever is the remainder value, whatever is the remainder value to our existing hash map. And then once we are done, we will simply return the value of the count. So let's see if this works. Yes, this works. And let us submit this code. So yeah, it's running, it's like 73.74% faster than all the solutions. Usually don't be too much concerned with what like how fast your solution is, because the Leetcode is not very reliable in this way. At least I have seen, like, for the same submission, it will give different results. But anyways, it's like you can still just see how fast or slow your code is running. And for this one, the time complexity will be order of n. And the reason for that is that you are running this loop for t in time. Other than that, for anything related to HashMap, looking, searching, adding, everything will be constant time, and the space complexity will be order of n because we are using the hash map. So this is the result that you get, and this is the code for this question. Um, so yeah, guys. This is a this is a great question. And particularly the question is very similar to two-sum question, and the only thing is the mathematics that is involved in the modulus operation. But I hope it is clear to you. If you have any questions, any comments, please leave it down in the comment section. I'll try to answer that. And we'll see you in the next video. Till then, stay safe, stay happy. Bye.